Hello, everybody. My name is Nicolas Catellier. I am an architect and BIM manager. I'm also the founder of the website revitpr.com. And I am the owner of a BIM consultancy firm called BIM Pure Productions. Prior to being a BIM consultant, I used to work as an architect, designer, BIM manager, and project manager for Atelier 21 Architect, based in Quebec City. The name of this session is called Modeling Complex Railings and Balusters in Revit. And the reason I became interested in this topic, as you can see in this image, I had to model a very complex railing for a renovation project of an ancestral building renovation in the old Quebec area. So I've got handed hand drawings of this railing, and that was a real challenge, a real puzzle for me. I wonder how I would do it. And I thought it would be better to do it without using model in place or generic families, just using the native Revit railing tools. So you can see some of the specific conditions I had to face in this project. There were curved vertical and horizontal transitions. There were different height on landings. There were posts with complex geometry. And yeah, this is the project called Maison Dauphine by Atelier 21 Architects. So I really decided to dig deep into all the railing properties. You can see this is a chart I made that contains every single parameter inside the Revit railing type. There's a lot of them. In fact, there are 63 parameters. So you can see how it is divided. You have all the rails on the right side, the top rail, handrails, intermediate rails, and the balusters and posts on the left side, plus all the type properties, pathline properties, and instance properties of the railing itself. So a lot going on there. In this presentation, obviously, you won't have time to cover every single one of these features. I'm going to stick to the ones that are most interesting or that are the most surprising to most users, the one that most users don't really know about. So hopefully you're going to learn something. So here's what we're going to cover today. We're going to talk about all types of railings. We're going to set up rail properties. We're going to talk about additional railing settings that can impact rails. Then we're going to move on to balusters and posts, and we're going to finish by creating an advanced baluster family, a classical baluster that I've used in the ancestral renovation project. Let's begin with the rail properties. In Revit, there are three types of rails: the top rails, the handrails, and the intermediate rails, most frequently known as non-continuous rails. That's how they're named in the Revit menus. Let's start with the top rail. The top rail has two possible loadable families, two RFAs you can load inside this system family. There's the 2D profile and the termination, as well as multiple properties. As you can see, they're all listed there. We're gonna go through most of them in this presentation. An interesting thing to know, the top rail is a system family, which means it will appear in your project browser, and you can use the same top rail in multiple railing types. The handrail is very similar to the top rail, except you have access to an additional loadable family, which is the support family, as well as additional type properties related to the support, like the support layout, justification, number, and spacing. But the rest is very similar to the top rail. And then the intermediate rails, which don't have a lot of properties. The only family you can load is the 2D profile. And then there are only 4 properties for the intermediate rail: the name, the height, the offset, and the material. And these are not system families, which means that for every different railing type, you have to redo them again and again. They cannot be shared among multiple railing types. I made this chart that compares all the features between the top rail, handrail, and intermediate rails. So you can see the top rail and handrails have access to most of these features, but not the intermediate rails. Intermediate rails are much more limited. They can have a custom profile and you can assign them to balusters, but you don't have access to the rest of the features. And the top rails and handrails are very similar, except for the handrail, which doesn't have access to assign to balusters. Balusters cannot be constrained to a handrail. However, a handrail have access to the supports tool, which is exclusive to handrails. You cannot set support to the top rail. So in this presentation, we're going to talk about most of these features, not all of them, sadly. But if you have a look at the handout, we go over to even more of these features. So let's start with the most basic one. I'm guessing most of you are familiar with this one. This is the rail profile. At the bottom, you can see a rail profile family. It's very simple to create. It's just a bunch of lines, and just make sure the top of the profile matches the center reference plane. You can see the result when we place the profile in the top rail, like in this example. So something perhaps a little more surprising that most of you don't know much about is the termination families. So the termination are actual model families similar to generic model families, for example. It's actually a 3D component. And the way I've created this one, as you can see here, we didn't like this, the end of this railing at all, the end of this rail at all. It's way too sharp. And if it extends, it can almost be dangerous. So we've created this fancy termination that is much more beautiful and suitable for the renovation project. And the way we've done this is by importing the profile, the rail profile family, and creating a sweep for it, and then creating a model void extrusion to cut the geometry, like in this image. And then when the family is complete, you can load it up to the project in the rail properties, in the top rail properties. We've set up both the beginning and end termination. We've set it to the ancestral termination. And on the bottom image, we've decided to add it to the handrails as well. For those of you, if you want to create a 3D presentation view where you can show this top rail that includes the termination, and you will see that there are lines like this. So perhaps you don't like that. So you can use the Lineworks tool, which is a tool I don't usually recommend because it's not the best BIM practice. But for the purpose of a presentation 3D view, it is fine enough. Just select invisible line, click on the lines to remove them to have a neat presentation view. If you have a custom path at the end of the rail, like with an angle or curve like this, normally the termination should be following the angle. All right, so here's a little video that recap what we've been talking about. First, we're looking at a profile. This is the ancestral profile. We load it back into the project, edit the rail properties, then go to the top rail settings, go to profile, and then we switch the profile to the ancestral top rail profile, just like this. And if you zoom in to the railing, you can see that it now uses the profile we've been creating. So that's simple enough, right? So let's move on to something more complicated, termination. So you can see this is a termination family created with a sweep. And we can see we've created a void extrusion to cut it kind of a neat way at the end of it. Load the family back into the project, go back to the top rail properties. You can see the termination, both beginning and end, set the family to it, and you can see the family is placed. So just something to be aware of. The material has to be set independently for the termination and the rest of the rail. So don't forget to set the same material so you don't get two different colors like in this example. All right, now let's talk about the extensions. Most people think there are 3 types of extensions in Revit: floor, post, and walls, like you can see in this example. But there's a 4th one that is simply called none. You can set an extension even if the extension style is set to none. You can see here we have an extension of 300 millimeters. And in this case, it will just be a straight extension. While a floor goes down all the way, the top rail will go all the way down to the floor. The post will create a return like this at the halfway point of the railing. And the wall extension style is usually used for handrails. You don't really use this for top rails. It is to create a small return to match the railing pathline. There's a special features for extension, but that is only available at the beginning or bottom of the stairs. And that is the plus thread depth. You can see on the left image, when this feature is activated, the top rail will extend for a length equivalent of a thread depth. As you can see here, while when this option is inactive, you can see there's no further extension except for the 300 value set. So we've saw 4 different types of extensions you can use, but actually you can draw whatever you want using the custom extension path. So to accomplish this, you have to tab, select the top rail or handrail, click on edit rail, click on edit path. Then you should have access to the draw tool. You can draw any shape you want, click the green check to complete, and that's it. The only constraint you have, you're constrained to a single plane. So you cannot have some sort of fancy 3D profile that goes all around. You need, you're stuck with the basic plane of the top rail. So here's an example of it. Let's start with recap the extension again. In this case, we use the none extension. Set a length of 300 millimeters. Click on apply. You can see it goes straight. Let's switch to the wall. In this case, wall doesn't have any effect because it's the top rail. It's already centered on the railing path line. So for this to have an effect, it would most likely need to be a handrail. Now let's try the floor. It goes all the way down to the floor. Then post, which will create a return at the halfway point. And you can see what happens when we activate the plus thread that feature. Let's try to create a custom extension path by clicking. You can see we selected the top rail, clicking on edit rail, then clicking on edit path. That gives you access to the draw tools. And now we start to draw any shape you want like this. You can add curves if you want. And hopefully, normally, it doesn't always work, but most of the time, the termination should be matching the top rail profile as well. So we've talked about extensions. Now let's talk about transitions. There are 3 types of rail transitions in Revit: none, simple, and gooseneck. And if you ever saw the warning, as you can see, which says the rail is not continuous, that is a very frequent warning, especially if you try to model stairs, a U-shaped stairs, you will most likely get this warning, especially with the default Revit template. And that is probably because you are using the none or simple rail profile, rail transition, sorry. And if you use the gooseneck style, you will most likely not get a warning. If you use none, you will always get this warning. That's pretty annoying. So none is not a suggested option. So the rail joint, this is one of the features I discovered while creating the ancestral railing. Because you can create little curves like this. If you go to the top rail or handrail properties, you have an option called the default join. In almost all cases, it will be set to the default option, which is miter. But you can change the default join to fillet, like on the right example. And then you can set a fillet radius. In this example, we've set a fillet radius of 50 millimeters. And that affects not only horizontal transitions, but vertical transitions as well. As you can see here, we have a radius of 50 millimeters, as well as for the vertical transition. So that will affect every single transition in this railing type. Maybe for you, that's too broad of an effect. That's okay, because you have access to this option to modify the individual join. So if you tab, select the top rail or handrail, click on edit rail, edit path, and then edit rail joins. So quite a long way to get there. Edit rail, edit path, and then edit rail joins. And then you should see the snap icons like this. And in the options bar, you have access. You can change the style. In this case, we change it to fillet, and you can set any radius value you want, like in this example. So that is for individual joins instead of affecting the whole railing. As you can see, you might have issues with balusters though. So let's have a look at this video. First, you can see the transitions here are currently set to gooseneck. So there are no transition issues, although they're quite a little complex. Perhaps it's not exactly what you want. So we switch the transition to simple instead. You can see already we got a warning. So what's going on here? You can see the transition here still looks fine. It's really at the center here. You can see that the top rail breaks, which is probably because of the complexity of the rail profile. With a more simple railing, perhaps that would have been okay. But still, you get a warning. But even worse, if you select the none option like this, you can see that you still get a warning, and the transition don't make sense at all. So you probably should never use this kind of option. I guess there are probably certain exceptions. So for a moment, we keep it to gooseneck. Now we'll talk again about the join setting, mitter or fillet. Go to the top rail properties once again. You can see here, the default join is currently set to mitter. Now we switch it to fillet and set a fillet radius value of 50 millimeters. And check that out. Check out what happens. So the rail get kind of curvy, almost gaudy style, right? And you can see it has a radius value for both the vertical transition like this and the horizontal transitions like over here. So it has a broad effect on every single joint. Let's try to modify the individual joints. So tab select one of the top rail by using tab, then click on edit rail, click on edit path. And finally, click on edit rail joints. So quite a long way to get there. Then with the snaps, you should be able to select one of the transition, select it, select fillet, and then you can set any radius value you want. So in this case, 200. So you can see we have the radius we want, but once again, you can see there are some problems with the balusters. So for horizontal transitions, this option can be a little tricky with the balusters. So that's why in this case, you might use the actual railing path to create a little curve to make sure that the balusters will also follow along with it. All right, so we saw settings that are specific to top rails or handrails that you have to enter these system families. Now let's talk about general railing settings that have an effect on all type of rails, on both the top rails and handrails. First, the railing direction. So you might be seeing these little arrows that represent the beginning and end of a railing. That's helpful not only to know where's the beginning and end, but also to know what side is the right side and what side is the left side, which is helpful when you're placing handrails, for example, which you can either place on either side of the railing. And you can switch the side of the railing by clicking on one of the arrows. And if you have a railing that is placed on the stairs, the beginning of the railing is always at the bottom. You can see an example here where when we switch the side of the arrows, the placement of the handrail will be switched. So the position is on the right side, but the right side is relative, right? It's relative to where the beginning and end is. So that's why when you switch the direction, the position of the handrail also switches. Let's have a look at this video. So let's have a look at the type of this railing. You can see that the handrail is placed on the right side on this one. You click on edit path, you can see the path arrows. And when you click on the arrows, the right changes, right? So that's why the position of the handrail switches. So that's something to be mindful of. Now let's talk about tangent joints. That's another option that has an effect on all rails in your railing type. And you can see there are three options: extend rails to meet, no connector, and add vertical or horizontal segment. The no connector option doesn't make a lot of sense. You can see it creates a very odd transition here. And the problem with extend rails to meet is if you have a minimum landing height, for example, perhaps you won't meet it. You can see here it is this part of the railing is lower. So the add vertical or horizontal segment is usually the best option for tangent joints, and also for angle joints, which is a different parameter that is used only when there's an angle in the railing path. So you can see in this example, we use the no connector option. Again, that's kind of an odd joint. It's probably not what you want. So you should stick to add vertical or horizontal segments. Let's talk about the landing height adjustment. On the image on the left, there is no landing height adjustment. You can see the railing height is the same on the stairs and on the landing, 500 millimeters in this case. On the image on the right, on the stairs, the railing is 500 millimeters height. But on landing, since we've activated the landing height adjustment and we've set an offset value of 300, you can see the height of the railing is taller, goes all the way up to 800. That's because of this feature we've activated. If you think that is too broad of an effect, it is also possible to set a height correction to individual path line of the railing. So for example, here we select this path line. In the options bar, there's a parameter called height correction. We set it to custom and enter a value of 300. So instead of having the whole landing with landing height adjustment, it is just this individual segment. And this will override whatever you set in the type properties. There's another option most users don't know about, that is the slope override for each railing path line. In this example, we select the line over here, and in the options bar, we set it to sloped, which will create a slope between the two adjacent railing path lines. So it will link the two with a slope segment. So this railing was actually created with a single type just by messing around with multiple segments, playing around with the height correction and the slope override feature. So you can get pretty interesting results just like this. So let's showcase what we've just learned with a little video. You can see a S-shaped railing. Select one of the path line, set a custom height correction, in this case of 300, then do it for another segment. In this case, we add an offset of 600. You can see the offset difference for each segment. And then let's try to create a slope for the middle segment. Set the slope to sloped instead of by a host. And as you can see here, it creates a slope to link the two segments. So pretty interesting feature that most people don't even know it exists, right? That's it for rails. Let's talk about balusters and posts. So posts are at the start, the end, or corner of a railing, while balusters are in the middle. And there's a baluster family and post family, which can be very different. Let's talk about a few tips that would surprise many users. One is to vertically align balusters. You can see here at the bottom, we have thick balusters, and on the top, we have much thinner ones. And the way you can accomplish that is, in this case, we have an intermediate rail. So for this first baluster, the base is the host, while the top is the intermediate rail. And the second one, the base is the intermediate rail, while the top is the top rail. And the feature that is key here is that the distance from previous for the second baluster, for this one, is set to 0. And that's how you can vertically align them. And then you can have fun with the offset. In this case, we've set base and top offsets for both of these balusters, so they don't necessarily stick to the position of their host. Setting the justification, I know that can be very confusing for a lot of users. The best option is usually spread pattern to fit, to have the exact same distance even at the beginning and end for the balusters. The problem with this is if you want an exact centered center value of 100 millimeters or 4 inches, for example, you won't get exactly that. So you can see this is set to 100, but the actual value is 107. So if you want to be really precise, you'll have to use another option like bidding and or probably center, which is you're most likely to find useful. Something that confuses a lot of users as well is the use balusters per tread on stairs option. And when this option is checked, the main pattern of the balusters will be completely ignored. It doesn't have any value. And only the options you set over here will have an effect on the balusters. And you can see, for example, over here, we have 2 balusters per tread. On this one, we have 3 balusters per tread. And then you just need to select which family of balusters you want to use. There's a few quirky effects for the balusters. For example, here we set an actual tread depth of 250 millimeters. On this one, 350. And you can see that the spacing between the balusters is different depending on this value. And I have to mention this annoying glitch when you have a railing like this. The balusters, sadly, they won't extend all the way to the floors, to my knowledge. There's no way to fix this, no workarounds. That is pretty annoying, but you know, what can you do? All right, so let's have a look at this video. using balusters per thread on that. Let's go to you can see both these railings are using the same type. But if we go to the baluster placement and check the use balusters per thread option, click on OK, you can see that suddenly these two railings, even though they are the same type, the one on the stairs has completely different balusters because we've activated the balusters per thread on the stairs option, which means that the main pattern is ignored once again. And again, let's try to play with actual trap depth. If you modify it to 350 millimeters, for example, you can see the spacing between the balusters is modified. Let's talk about the offset value on balusters. So if you use a positive value for the balusters, the balusters will be pushed to the left side of the railing. If you use a negative value, they will be pushed to the right side. So that's good to know. You can refer to the image if you are confused. Let's talk about posts. So there are three types of posts in the baluster placement menu. The start post, as you can see in this image, the end post, which is located at the end of the railing, depending on the arrows can guide you with that, and the corner posts, which are at the corner, or as you will see later, when you interrupt the railing path line. There's also the space value on posts. For example, the option which makes the most sense is to use a positive value for the end post and a negative value for the start post, just like this. Else, you might get weird results, like in this example. If you interrupt your railing path segments, you will create additional corner posts, just like in this example, if you have the option turned on. Let me show this with a video example. So you can see here we add a railing segment line like this, and you can see it creates an additional corner post at where the railing path line intersects. And you can see in this example that the corner posts are taller. So you're going to see how we managed to do that. Go to the baluster placement menu, and you can see that the corner post has a top offset currently of 250 millimeters. Let's switch that to 500 instead and try to see what happens. So you have to quit the menu to see the actual effect, and you see they grow taller just because of the offset value we've set. All right. To the final part of the presentation, creating a classical baluster family. So in the ancestral renovation project, we've had to create a baluster just like in this image. So that's from an old book. I've scanned the image and cleaned it, and I bring it to the family editor to use as a reference. So on the right, you can see this is what you see when you create a new baluster family. And what I like to do immediately, especially in this case, is I create new reference planes. I like to use a different color, in this case, a pink, purple color. And then I lock the middle dimensions to a value of 500 millimeters, which is determined by, obviously, the geometry of the baluster. Then use the revolve tool and make sure to use the correct reference plane. Then you can use the image as the reference and draw the profile of the baluster, just like in this image. Then you need to select the axis line tool and draw the axis. You can use the pick line on the central reference plane. When you're done like that, your baluster using the revolve tool should look like this, like the central section. And then you still need to create the top part and the bottom part of this baluster. So create an extrusion tool and make sure to use the pick lines tool and select all the 4 lines, including the angle lines that you should see, and use the trim tool to trim them properly. And then in the plan view, lock them so they are square shaped like this. Again, make sure to use the lock icon and do the same thing for the bottom part as well. In the end, you should have something like this, with the middle main part of the baluster and the top and bottom part of it. You can verify in the 3D view to make sure it is okay. And the next thing you need to do, go to an elevation view and add EQ dimensions like this. And the reason we do this is that the excess height will be redistributed equally on the top and bottom of the baluster family. And finally, make sure to add a baluster material to assign it to the family, so you can switch the material once it is loaded inside the project. Then you're ready to bring it back to your project. And when you set it up, you can see the railing height on the left and the railing height on the right are different. You can see the effect on the balusters themselves. So the middle part is fixed, the dimensions don't change, only the top and bottom part of it will be modified. So let's have a look at this video, which you can see inside of the family. When we switch the baluster height, you can see the middle stays fixed, but the top and bottom are modified. In the 3D view, you can see the revolve shape we've created using the image as a reference. And so let's try to modify this railing using the balusters we've created, replace these kind of boring balusters with the classical one. So click on Edit Type, go to the baluster placement menu, click on the baluster family, and then you replace it with the classical baluster. And if you zoom in, you can see what happens. We see we've replaced it with the classical balusters, and what's neat about it is that you can see even when there's a slope like this, the top and bottom shape will adapt to the slope to have a correct geometry, just like in this example. All right, so that's it from this presentation. I know that was a lot of content. In the handout, there is even more. All the steps are properly described. So if you thought for any reason I went too fast, make sure to refer yourself to the handout. It is very complete. So thanks a lot to everybody. And then we'll move on to the Q&A session.